Recursive formula follows the basic principle of arithmetic sequence, which is adding or subtracting the current term with a common difference. Learn the details here in Mathematics of Engineering. Given a specific number pattern with a common difference of 4, we can determine the recursive formula by using the format a sub n is equal to the previous term plus or minus the common difference d. With this template, the difference will be placed as it remains constant all throughout the pattern. So the recursive formula for the arithmetic sequence is a sub n is equal to the previous a sub n plus 4. Now check the terms. So a sub 2 is solved by a sub 1 plus 4, and that is 4 plus 4, which is 8. A sub 3 is as a sub 2 plus 4, and that's 8 plus 4, resulting to 12. A sub 4 is a sub 3 plus 4, or 12 plus 4, which is 16. Having all terms similar with the pattern, the rule is a sub n is equal to a sub n minus 1 plus 4. With a pattern involving 5, 8, 11, and 14, the common difference is taken as 3. So plug this value in the recursive formula to have a sub n is equal to the current term plus 3. Now check the validity of the formula by applying it to the other terms. For a sub 2, which is a sub 1 plus 3, or 5 plus 3, that is equal to 8. A sub 3 is a sub 2 plus 3, yielding 8 plus 3, which is 11. A sub 4 is also taken as a sub 3 plus 3, or that is 11 plus 3, which is 14. Everything is coincident with the terms in the pattern, so the rule of a sub n equals to a sub n minus 1 plus 3 is correct. The next example with 12, 9, 6, 3, and so on shows a common difference of negative 3. So with the recursive formula, the specific rule for the example lies with a sub n is equal to the current n less 3. Now check the succeeding terms, starting with a sub 2, which is a sub 1 minus 3, or 12 minus 3 to give 9. A sub 3 is a sub 2 minus 3, or 9 minus 3, yielding 6. A sub 4 is taken as a sub 3 minus 3, that is 6 minus 3, which is 3. 9, 6, and 3 are the succeeding terms after 12. Once again, with the pattern shown, the common difference is determined as positive 2. And this is placed in the recursive formula to have a sub n is equal to the current term plus 2. The next step is to check the other terms. So start with a sub 2, which is a sub 1 plus 2, or negative 3 plus 2, and that is negative 1. A sub 3 uses the same formula, which turns as negative 1 plus 2, resulting to positive 1. A sub 4 is 1 plus 2, and that is 3. And a sub 5 is 3 plus 2, or 5. All of which are values in our arithmetic sequence. Evaluating a recursive formula is simply the opposite procedure. So with the first example, where the recursive formula of a sub n is equal to 264 plus the previous n, the initial term given as negative 29. All we gotta do is to substitute a sub 1 in the pattern. So start with a sub 2, which is 264 plus a sub 1, that is 264 plus negative 29, and it is 235. A sub 3 is 264 plus A sub 2. That is 264 plus 235, which is 499. Then lastly, A sub 4 is 264 plus A sub 3, which is 264 plus 499, resulting to 763. Here is another example to showcase evaluating a recursive formula. With A sub n equal to A sub n minus 1 plus 34.3, where A sub 1 is 59.6, A sub 2 is solved by plugging the initial term into the formula, that is 59.6 plus 34.3, giving 93.9. A sub 3 is 93.9 plus 34.3, or 128.2. And the fourth term is 128.2 plus 34.3 to get 162.5.